Welcome back to the channel, you guys. Welcome back. I'm Big B. All right. We got the Deltaforce Vortex 24 twin motor hydroplane on the block. All right. This is a build series part 2. We've already got the hatch locks on the boat. We got the carbon fiber inlay done. Previous part 1, we made the 2-in-1, well, I guess 3-in-1 motor servo mount out of some carbon fiber. We may get that in the boat today, possibly. Today I want to concentrate on hardware. I want to get the turn fin mounted up before we run out of room to get to it. Go ahead and get this mounted in the boat, and we're going to play around with hardware. We're going to mess with the strut setback, the rudder setback, and I really want to get these mounted up. Okay, so stick around. Big B with Ironclad RC. So I'm actually going to try to pick up where I left off in my last video. We were actually talking about hardware, center of gravity, motor position, and all that. So first of all, this is kind of a out-the-box build. You really don't see, or you can really not find information online or setup information about twin electric hydroplanes. Now, you can find some information about twin motor nitro and gas riggers, some electric riggers, but twin hydroplanes, there's not a whole lot of information out. So I'm kind of winging it here, to be honest with you. Now, I've already built that drag boat, and it was a success. It was fast, it ran good, and I'm kind of using some of that knowledge I acquired from that build on this one, even though my ride pad was farther forward on that boat. I'm basing this build on that one, basically. So in my last video, I was saying that I really wasn't sure about this setback, you know, running these props like this far back. I kind of like the idea, because if you extend the props off the transom or the struts, you know, you're basically lengthening the tunnel of the boat, you know, and I'm having to run my motors back in this thing for clearance issues. So trying to get my center of gravity farther forward, it's kind of tough on me. So extending the struts off the transom, it kind of makes sense, to be honest with you. But I'm kind of worried about the handling aspect. It will probably handle just fine like this, you know. But my drag boat with the struts like mounted right up against the transom, it handles so freaking good. I'm thinking that this may handle better in an oval, and with them tucked up, it may handle better in a straight. I don't know though. I don't know, because you're going to have more leverage back here. So any little minute adjustment you make with the extended strut, it's going to be like ×2, basically. You feel me? That's my thinking anyway. So I was thinking about, if I run them extended, I was thinking about cutting my bracket short on my rudder. You know, running my rudder like right here, so that when it kicks up, if I hit something, it's not really going to hit my props. But I'm kind of second guessing that too. So, you know what? Let's see if I have the brackets that I had on my drag boat, or if I have a different set of brackets we can run for this thing. Let's check it out. Let's see what our options are here. All right, so this is just a box of hardware. This is what I keep some of my older hardware in. My new stuff, some of my new stuff. So okay, so I use turn fin brackets as my my strut bracket on my previous build. You know what I'm saying? I use a turn fin bracket. So let's look at I got this thing organized, rudders. So let's look in the turn fin bin here. 3, so that's not gonna work. Oh, there we are. Is this it? Is this it right here? Oh yeah, this is, oh, I do have them. Do I have all 4? Yes, we got them. Yeah, that right there will get it up on the transom. All right. These would actually get it closer to the transom than the plastic bracket. Let's take this out and let's see what that looks like too. Alright, so I got a freaking mess here. And I just went down a rabbit hole. I'm talking, I've been sitting here for the past 2 hours working on rudder setback. I've made these like blocks to put under my rudder. I've actually cut a rudder bracket short, which is what I have on here now. This is the original one. This is the short one. I was actually contemplating trying to use this for a rudder bracket. I had this old bracket in that box. I was gonna, you know, I've been messing with setback on this strut and rudder. Long story short, it was a rabbit hole. Okay, so what I really want to do, like I said, is try to keep my prop close to the transom. All right. In order to do that, I really got to run an extended rudder off, well, behind the props, right? I don't have one at the moment, and I really got too much invested in a couple projects right now, and I can't order one. You feel me? And I looked through everything trying to find something that'll work. Now I could modify this big bracket like I did that Miss Geico 2024 and cut it down and get it to right, you know, but I really wanted everything to kind of match on this boat. That's the reason why I'm ruling out the plastic base, which would actually work perfect with these struts. I'm ruling that out because I want everything to match. All right, so I cut the rudder bracket down, okay, and I wanted to show you guys the setback here. Okay, this is what I really wanted to run, and I'm not going to be able to run that with the current rudder. Even if I use the original bracket, it's just not going to work. It's going to run into the prop. Okay, so I'm kind of ruling it out. And I really hate to, but I've already run a hydroplane with my strut forward. I know it works in a straight, so I'm actually kind of curious to see how it works with the extended strut. You know, with the extended strut, I got my gap here for my drive dog. Not gonna hit the prop. All right, you guys see that? We're not gonna hit the prop at all. Okay. When it kicks up, it may hit the prop. You guys see that? So I've actually seen guys put a spring on the rudder. When it kicks up, it'll pull itself back down, and that'll actually limit the amount of kickback it'll have. So I'm contemplating that. I think I'm going to go with the extended strut, rudder in front of the prop. If we need more steering authority, we can use the longer rudder to get the more rudder in the water, because with the props behind the rudder, it's going to want to blow out, and we're going to understeer. I'm afraid if we put the rudder behind the prop, it's going to oversteer, especially in a turn. The blast off the propellers hitting the rudder is going to create an oversteer effect with the turn fin. That's what I'm thinking. So with a hydroplane, I'm thinking having an understeer effect in conjunction with the turn fin. It should be kind of on the money. That's what I'm hoping. So extended struts, final answer. This whole rabbit hole, I'm talking, I went down it, boy. So with the rudder, bracket short, I can run my struts. I can run these struts in their forward position. It brings it a little bit closer to the transom. They're not fully extendo, and it won't hit the rudder, you know, and it may actually work out better when it kicks up, because the props will almost be in front of the swing on the blade, you know. So yeah, I'm done with that. Final answer. I'm gonna go ahead and mark this strut height right here because that looks pretty good. We'll match this up all the way across the board. I'm gonna pull the double side tape off, and we're gonna go ahead and start laying out our permanent like lines. I'm gonna have to peel this damn tape off of here. It looks like, oh yep, I definitely am. Okay, and this rudder, I'm gonna drill the holes for the rudder after I get my struts marked out and the holes drilled for my struts, because I want to make sure I got this blade dead nut center. It's not really the best rudder center mount, you know, because the bracket's all set, the pins, like, yeah. So we got to make sure this pin right here is dead nut center on our center line, you know. I was kind of contemplating, you know, my motors, my motor width from one another, the distance they are 60 millimeters. You know, I was thinking about running 65 on my struts, 60 on the motor, 65 on the struts, and just kind of putting a little slight S-bend in my stuffing tube. Contemplating it. Man, there's so much stuff that you got to think about building a damn boat. You don't even realize it, but I mean, there's so much that goes into it, man. It's crazy. Like, you know, you think about this, you think about that. What if, you know? So I got the transom all cleaned up here, and we're going to try to find center real quick. Okay. So I usually just go from the outside corner, find center, and hope that the boat's plumb and true, you know. Hope it's true. All right, center right there. Find center. My motors are 60 millimeters to the center of my motor. Okay, so that's 30 and 30. All right, so I'm going to take from center pull 30. I'm like going blind, boys. Can't see like I used to. Check that out, make sure it's 60. Alright, looks good. Center on my strut, center on this strut. Okay. Alright, so I took everything out my boat so I can put my hull in my lap, hold it straight up and down. I can find center on this bracket right here. Okay, and I can mark out my hardware. Alright. Okay, so you guys see that bottom line right there? I'm going to use that for my hole, my bottom hole. You see that? So I know I get it right. Basically going to do the same thing when I drill it, just so I can see it better. When it's sitting up here in the light, my eyes, I feel I can get a better judge like this. Okay, I'm holding my rudder where I think center should be. And okay. Alright, so I got my bottom hole for my rudder drilled, and I'm just basically eyeballing it here. Make sure it's vertical. There's no cant in it before I finalize that my last hole here, you know. From what it looks like here, 62 millimeters center to center on my prop shaft, and my motors are 60, so I went out a millimeter here and here, and that should be okay. It ain't gonna hurt nothing. I'll work it out with the stuffing tube, you know. So I got the rudder drill. It looks straight, vertical, you know. Everything looks pretty plumb in my opinion. So I got the 4 millimeter cables in here, and I'm putting my Teflon washer on. I usually don't use a Teflon washer on a lot of my boats. It's actually a really good idea to run a Teflon washer. That way, if your cable contracts or you don't leave a big enough gap, drive dog to strut, and the cable contracts, the drive dog won't rub on the strut, you know, metal to metal. So it's a good idea to run Teflon washers. They have really nice ones that have like ball bearings on them, and those actually are really good. You can actually run a very little gap, and the prop will ride on that ball bearing Teflon washer, and it won't put radial loading on your forward motor bearing, you know. So yeah, it's a good idea to use Teflon washers. So these flex cables actually come with a Teflon washer, which feels like it's too freaking big, a drive dog, a bullet nut, and a lock nut. I don't like bullet nuts, but I'm going to throw the bullet nut on for the time being, just because it don't have the lock, you know, that nylon, and I can just screw them on and off when I need to, and they look cool. I kind of stay away from them because they tend to unscrew and you lose the props easy. If you're running bullet nuts, use blue Loctite every time you put them on. Sometimes you have to actually clean the tip of it out because the blue Loctite will fill the tip of it, and you know, you won't be able to get it all the way on. So you have to kind of clean it out every now and then with alcohol, but always use blue Loctite. I like these 4 millimeter cables for smaller boats, you know, and I don't know, 18 to 24 inch range. They work good. I like them because they're cheap. On these twin motor builds I've been doing, I've been running the 4 millimeter counter rotating flex cables, and it's the loads being shared, you know, between the two of them, so they're all right. I haven't really had a whole lot of issues with them breaking, you know. I haven't twisted one yet. I think I did break a connection one time, but that was really, I think that's the only issue I've ever had with the 4 millimeter cables. Now 3/16 shafts have more drive dog options, more strut options, and more flex cable to stub shaft options. Eddie sells a 4 millimeter stub shaft to a 0.130 cable, which is good for light boats. That 3.130 cable wouldn't work for this boat with the power I got in it and the props I'm trying to run. I mean, it probably would. It didn't work on my Deltaforce 29 to 0.130, which is smaller than a 4 millimeter cable. And I run the 4 millimeter cables because on these smaller builds, the twin motor builds especially, simply because the strut and stinger options are smaller and more compact. That's really the only reason I run these 4 millimeter cables. And you get a few more propeller options, like on my riggers. I especially like the 4 millimeter cable on my smaller riggers because I can run this 3619. I've got a couple of them that I've cut down and modified, and it's a fast ass little prop, and I think it's going to be good on this too. You know, it's not a true 1.9 pitch prop. it's not. Like, it's not. It's like this is more of a true 1.9 pitch prop. This is not. Even though pitch ratios are the same all the way across the board, the blade is detongue and shaped like a high rake prop, you know, but it's not a high rake prop, but it's got the blade shape of a 1.9 pitch prop, you know. It's actually a pretty quick prop. It's basically a shrunk down version of that 4519 Oxstein prop, which is a cool running prop. I don't see how guys are like, oh, the 1.9 Oxstein's not a 1.9. There ain't no way. I tell a lot of guys that 1.9 pitch Oxstein 4519 is a cooler running prop on the Sonic Wake. It is. And if it was a true 1.9 pitch, like high rake prop, like, you know, like a true 1.9 pitch, it would not be a cooler running prop on that boat. So that actually looks pretty good. That looks pretty trick. Let me get off my little tangent there. Yeah, that looks nice, man. So when the rudder kicks up, this is what I'm so worried about. Oh, with a little gap there. Oh, it's gonna miss it. It's gonna miss these high rake props, it looks like. So I really need, I shouldn't have filed it all the way up top. I should have only made it where it kicked up this much. You know, when it hit something, it'd kick up that much and that's it. Oh, I should have done that. I didn't even think about it. Oh well, too late now. I don't know how I'm going to videotape this, but I'm going to do my best. All right. So I got a file in my hand here, and I'm turning my boat up. And for one, I'm cleaning up those damn spikes from the carbon fiber inlay. Them things will send splinters in your finger, and they're tough to get out. But I'm also basically just making sure my mounting surface for this right here, making sure it's flat. You know, been working a file in there, got a couple different files I was working, some sandpaper, and just making sure it's flat, so whenever I put this in there, I'll have good waterproof adhesion. Well, I tell you guys everything. I went to go tighten this down. I had the epoxy in there, and I stripped out the top screw. So I'm going with my normal method. So I went ahead and made a carbon fiber one, and I used some baking powder to kind of reinforce it, and I've actually glued it onto my damn finger here. It's stuck on there. So I've just recently started using CA for my nut plates, and the only reason I do it here lately is it's quick, it's fast. Actually, this is the only boat I've done the CA other than my wood boats. It works good on wood boats, nut plates with balsa or birch. I used it on this, and it seems to be holding pretty good. And hell, I'm going to smear RTV all over the top of it so it waterproofs it. It's going to be epoxied into the sponge, and hell, nobody's going to freaking see it. Nobody's going to see it. Only about 1,000 people, you know? Alright, so I got my nut plate in there. You guys can't see it, so I'm not even going to try to show you, but it's epoxied in, and then I'm going to take some blue RTV and smear over the nuts, so my screws will go into the RTV. It'll waterproof it, and won't have to worry about any leaks. I got some, that's as much cant as I can get in on it. It'll go perfectly vertical as well, but I got it tightened up. It actually looks pretty good. So with that swept back turn fin, I think I did make the right choice running the extended struts. You know, I think I did. That should bring my center of gravity back a little bit, or allow me to run my center of gravity back with that swept back fin. I got them forward right now. I think we're going to start off with them extended, and then if we don't like them extended, we can slide it forward, cut the stuffing tube, cut the cable, and we'll be in business. All right, I think I am going to actually try to make a little spring so this rudder don't kick back too far. It'll kind of kick back and go back into place. That's something I've been wanting to do. I see a lot of Philippine or Asian guy, and it actually looks pretty trick, you know. So what might be a good project. Next video, getting the motor mount in between videos, I'm going to reinforce this transom. I'm going to lay it over the top, the back, and kind of overlap. It's a lot of hardware back here. In a crash or something, man, it might rip something apart. So we're going to do the inlay off camera. I'll show you what it looks like when I'm done. And I appreciate you guys watching this long video. Maybe you learned something, maybe not. Hopefully you guys like it. It's coming together. It's coming together, boy. Yes, sir, buddy. We'll see you guys next time. Thanks for watching the twin motor hydro build. Ooh, doggy.